Okay, now as I said today, we're going to look at integration because I was actually amazed at how many of you wrote integration down as being a problem. Okay? Now you seem to have a problem on both sides. I would imagine you find areas confusing, am I right? Okay? People generally find areas very confusing. So what I'm going to try to do is I'm going to try to cram in as much as I can. But there's a lot of different integrals, so maybe we might kind of end up doing a bit of integration tomorrow as well. Okay? I don't want to half do it. Okay? So first of all, for the first half an hour to quarters of an hour, I'm going to focus on how to actually integrate. And I'm going to show you some clever tricks as to how to do some of the more difficult questions. Okay? So first half, as I said, is how to. How to do it. Right, now I am going to make an assumption that I don't need to explain to everybody that if you integrate x to the power of n, you get x to the power of n plus 1 over n plus 1. That I don't need to explain that if you integrate sine, you get minus cos, and if you integrate cos, you get sine. I'm assuming we know the absolute basics. Is that okay? So I'm going to jump in where it starts to get just that little bit interesting. Okay? Now, integration, put simply, is the opposite to differentiation, isn't it? Put simply. There is no product rule for integration. There is no quotient rule for integration. There's no chain rule for integration. So we got a bit of a problem, haven't we? We have to know how to do integration by, what's the major technique we use? Substitution. Integration by substitution. Okay? Now, obviously, we need to be quite clever about the way we substitute. So what I'm going to do now is I'm going to put up on the board typical substitutions. But I want you to really focus on the word typical. This is not always the way it is to be done. Is that okay? I'll show you some exceptions as the class goes on, and there are even exceptions to the exceptions. Okay? But typically, these are the substitutions we would do. Number one, let u equal the bottom line. Okay? Generally. Not always, though. Now, what you're doing when you're integrating is you're looking at a question and you're actually thinking, if I let u equal that bit, if I differentiated that bit over there, would I get this bit up here? Or if I differentiated that bit up there, would I get this bit down here? You're looking for connections between the two different parts of the question. Okay? Now, my first example is going to be a really, really obvious one. Okay, so imagine I'm asked to calculate the integral of 2x minus 1 over x squared minus x plus 3 dx. Okay? Now, I'll explain later on where the dx comes from. Okay? At the moment, let's just assume that it's written there. Okay? When we're doing areas, I'll explain what dx means. It actually means a little bit of x, but my picture later on will explain it better. Now, instantly I'm looking at that and I'm thinking, well, you know what? If I differentiated x squared minus x plus 3, what would I get? I get 2x minus 1. So if I differentiate the bottom, I get the top. So it seems quite intelligent to me to make a substitution u equals x squared minus x plus 3. Okay? So then wouldn't that mean that du dx is going to be 2x minus 1, and then separate your variables. That's what this is called. Get the x's to one side, u's to the other. Wouldn't du would be equal to 2x minus 1 multiplied by dx, wouldn't it? Now, coincidentally, isn't that exactly what I have on top? Okay? On top, I have 2x minus 1 dx. So that's equal to du. So this awful looking integral on the left-hand side now just simply becomes the integral of 1 over u du. The integral of 1 over u du. As you see, 2x minus 1 is just du. 2x minus 1 dx is du. And the bottom line is just u. So 1 over u du. Now, what do you get when you integrate 1 over x dx? You get log x. So if I integrate 1 over u du, what do I get? I get log of u. Now remember, we have to think of differentiation a little bit here. If you differentiate 20, or 7, or 1,000,000, or any constant, what do you get? You get 0. If you differentiate a constant, the answer is 0. So when you're integrating, you have to allow for the fact that there could have been a constant. Okay? You have to allow for that possibility. So, this integral here, it's given a name. What kind of an integral is it? It's known as indefinite. Okay, why is it indefinite? We don't know what the limits are. Is that okay? It's known as an indefinite integral. So if you don't know what the limits are, it's called indefinite. If you do know what the limits are, it's definite. Okay? Now, because it's indefinite, I have to go from u's back to x's. So what was u equal to originally? Wasn't it x squared minus x plus 3? Okay? So that means that that's effectively going to become the log of x squared minus x plus 3 plus c. Okay? Now, I'm actually going to, for my first few integrals, I'm going to make them all indefinite so that I don't have to waste time thinking about limits and we can just get through stuff quicker. I think the idea is how do we integrate, not the tiny little bits. So let u equal the bottom line as one of our typical integrals. Substitution, sorry. What is our next typical substitution? There's lots, there's about 4. Now u equal the bottom line. Next thing, if you saw a square root sign, you'd be tempted to let u equal whatever's underneath the square root sign. Okay? So number 2. Let u equal what's under the square root sign. Okay? Well, here's a very cleverly disguised integral. Okay? I'm going to try to wreck your heads a little bit and make you think about trigonometry as well. Okay? Integral of the square root of tan x divided by cos squared x dx. The integral of the square root of tan x over cos squared x dx. It looks absolutely awful, doesn't it? Can anybody tell me, what does sec x mean? Doesn't sec x mean 1 over cos x? Would you agree? Sec x is 1 over cos x, and cosec x is 1 over sin x. Okay? So now let's think about 1 over cos squared x in a different light. Doesn't cos squared x on the bottom mean sec squared x on top? So, would we all be okay if I was to write down the integral of sec squared x by the square root of tan x dx? Now, how is that a help? Remember what I said. You're actually thinking in terms of differentiation. If I differentiate that bit, will I get this bit? So what you should be thinking is, do I know how to differentiate sec squared x? Ah, it's a bit of a headache. I'm not going to bother. Do I know how to differentiate tan x? What do I get when I differentiate tan x? I get sec squared x. Okay? So if I differentiate the bit that's underneath the square root sign, I end up with the bit that's outside the square root sign. Okay? So let u equal tan x. So du dx would be sec squared x, wouldn't it? So what would du be equal to? Sec squared x dx. Is that all right? So let's highlight this bit in yellow. The bit that I'm highlighting in yellow, sec squared x dx, is not the same as du. And what about the square root of tan x? Isn't that the integral of the square root of u du? Now it's much more reasonable, isn't it? Okay, I'm looking at it now and I'm thinking it's only a simple power of u. What does square root mean as a power? U to the power of a half, isn't it? Okay, so that's going to be equal to the integral of u to the power of a half du. And how do you do integration of powers? Add 1 to the power and divide by the new power. Add 1 to the power and divide by the new power. So isn't that going to be u to the power of 3 over 2 divided by 3 over 2? And sure, then it's an indefinite integral, so I better allow for c. Okay? If you forget to write down c, is it a numerical slip or a technical blunder? It's a technical blunder, unfortunately, isn't it? It's something that's supposed to be there and you've forgotten it, so it's 3 marks, not 1. Is that okay? Now, again, I can't leave it like that. Because I've substituted, I have to go back to x's again. Now, isn't dividing by 3 over 2 the same as multiplying by 2 over 3? And what's u? Isn't it tan x? So tan x to the power of 3 over 2 plus c. There's my final answer. Okay? So let u equal the bit that's underneath the square root sign. Usually it works quite well. Okay? We all happy with it? Right, now I want to do another one. That one, you see, the reason why I did that one is because the people in the project schools, it's quite likely that your integral is going to have some connection with trigonometry. Okay, hands up people again in the project schools. Okay, just a few of you. It's quite likely that your integrals are going to be trigonometric integrals. Okay, quite likely, most likely. Right, what about this one? This is another, well, I won't say which type it is. Find the integral of 2x minus 4 multiplied by the square root of x squared minus 4x plus 11 dx. What do you reckon here? Yeah. You obviously notice there that if I differentiate x squared minus 4x plus 11, I get 2x minus 4. But isn't that the bit out front, isn't it? So if I differentiate the bit under the square root sign, I get the bit out front. Okay? So again, the sensible thing to do is let u equal x squared minus 4x plus 11. So du dx is 2x minus 4. So du is 2x minus 4 dx. There's your 2x minus 4. There's your dx. Would you agree in the next line all I'm going to do is swap the bits in yellow for du and swap the bit under the square root sign for u. Is that okay? So this becomes the integral of the square root of u du. Which we've just done that integral. That's the same as the integral of u to the power of a half du. It's just that u is a different object this time. Okay? Add 1 to the power, divide by the new power. So I get u to the power of 3 over 2 divided by 3 over 2 plus c. Dividing by 3 over 2 is the same as multiplying by 2 over 3. Okay? And then u to the power of 3 over 2, that's going to be x squared minus 4x plus 11, the power of 3 over 2, and then plus my constant of integration. Okay? So do you all understand exactly what's going on there? So basically, if I see a square root sign, my gut reaction is I hope it's going to be let u equal whatever's underneath the square root sign. If it's not, I could have a problem on my hand. It could be one of the weirdest questions I can be asked. Thanks, Quiva. Sorry, if you could just sign and pass it on. And also as well, actually, Quiva was asking me if I could get you to write your email addresses after it. We need it for the college Moodle site so that you can log in afterwards. Is that okay? Remember I was telling you that this stuff is all going to be online. So if you put your email address down as well and write it clearly, in block capitals preferably, so that we definitely can't confuse it. Okay? Right, so next up. Next up, I am going to kind of build up to a seriously useful trick. Okay, that's asked year after year after year. Okay, so we're going to begin kind of stage 1 of 2 or 3. Right. Find the integral of 1 over ax plus b dx. Find the integral of 1 over ax plus b dx. Does everybody in the room agree that the bottom of this fraction is a linear function? What do I mean by that? It's a line, basically. The highest power of x is x to the power of 1. Okay, the highest power of x on the bottom line is x to the power of 1, so it's known as a linear function. Now, there is no square root sign, so I presume you'd all agree. This time it's not let u equal whatever is under the square root sign. This is most likely let u equal the bottom line. Okay? So let u equal ax plus b. Let's see where that brings us. U equals ax plus b. What's du dx? Just a, isn't it? Differentiate ax, you get a. Differentiate b, you get 0. They will tell you, by the way, where a and b are constants. So if you differentiate a constant, it's gone. It's 0. So du is equal to a dx. So 1 over a du equals dx. Okay? Now am I supposed to go back here with this information? Instead of dx, what am I going to put in? 1 over a du. And instead of ax plus b, I'm just going to put in u. Is that okay? So what are we going to get? We're going to get 1 over a by the integral of 1 over u du. 1 over a is constant, just to clarify something. 1 over a is constant, and constants can be pulled outside the integral sign. Multiplicative constants, constants that are multiplied, can be pulled out. Okay? Right, remind me again. Integrate 1 over u du. What do you get? Log u, isn't it? So that's going to be 1 over a by the natural log of u plus c, which is 1 over a by the log of ax plus b plus c. Okay? How many of you do applied maths? I know I teach some of you applied maths. Basically, in applied maths, these kind of integrals come up time after time after time. Okay? And the way you would always think of them is this. Isn't a the number in front of x? Can you please write this down, by the way? It's 1 over the number in front of x by the log of the bottom line. Just write that down. It'll make sense in a minute. 1 over the number in front of x times the log of the bottom line. So if you're integrating a constant over a linear function, it's going to be 1 over the number in front of x by the log of the bottom line. Any of you who are planning on going off to do degrees in engineering or anything to do with science, welcome to your future. Okay, logs are going to come up all over the place. Okay, so we're going to practice a little bit with logs here today as well. Okay? So 1 over the number in front of x by the log of the bottom line. So let's use that. Number 1. Very quickly integrate for me 4 over 3x minus 1 dx. It's obviously just like the ones we've just done, isn't it? The one we've just done. What's the number in front of x? 3. That's going to be 4/3 the log of the bottom line. 4 over 3 by the log of 3x minus 1 plus c. How easy is that? Okay? Next. Integral of 1 over 3 minus 2x dx. The integral of 1 over 3 minus 2x dx. What's the number in front of x this time? The number in front of x is minus 2, isn't it? So that's going to be minus a half the log of the bottom line. Okay, 1 divided by minus 2, which is minus a half of the log of the bottom line plus c. Is that okay? Number 3. Integral of 2 over x plus 1 dx. Let's just say there's a reason why I'm picking this one. Integrate 2 over x plus 1. What's the number in front of x? 1. Isn't it just 2 over 1 by the log of the bottom line? So 2 log x plus 1 plus c. So we all happy enough with what we've seen? Okay? Right. Last year. Let's just see how easy an integration question can be. Last year, question 8b part 1. I'm going to do all of the b part because you're going to notice that actually part 1 and part 2 are almost identical. They just have one annoying little difference. Okay? Also as well, actually, these are our first definite integrals today. So I'm going to show you how to deal with definite integrals as well. So this is last year, 2011. Question 8b. Where do you see this? Part 1. Integral from 0 up to 2 of x plus 1 over x squared plus 2x plus 2 dx. What do you reckon? What should be going on in your brain at the moment is you should be differentiating different parts of that like mad and seeing do you get other parts of it. What do you get if you differentiate x squared plus 2x plus 2? You get 2x plus 2. Isn't that exactly twice x plus 1? Isn't it exactly twice the top line? Well, that can't be too far wrong then, can it? So let's chance it. Let's be fair here. If I chance the substitution and it doesn't work, I'm going to find out really quickly, haven't I? Really, really quickly, I'll find out. So I'm going to chance it and let u equal x squared plus 2x plus 2. So du dx is 2x plus 2. But sure, isn't that? Sorry. Go away. 2 times x plus 1. Isn't it? Isn't it exactly double the top line? So if I cross multiply, I'm going to wind up with du equals 2 times x plus 1 dx. Is that all right? Now I put that all back over here. If du is 2 times x plus 1 dx, what's x plus 1 dx equal to? Don't I have to divide across by that 2? A half du equals x plus 1 dx. So instead of the top line, I'm going to be putting in a half du. Instead of the bottom line, I'm just going to be putting in u. Oh, good God, here we go again, another log. A half the integral of 1 over u du. And you're probably wondering why bother learning logs. Okay? They're unbelievably important. Okay, are we all happy that that just collapses to a half the integral of 1 over u du? Now, okay, different teachers do this different ways. The technically correct way, and I have to say you're not going to lose marks either way, but the technically correct way is that if you change letters, you're supposed to change your limits. Okay? You really should. Now, I know some people don't. It's not the end of the world, but it's actually easier to just change your limits. In other words, I'm never going back to x's again. Okay? I've moved to u's. I'm forgetting about x's. Okay? So what is u? U is x squared plus 2x plus 2. It's actually easier to do this anyway. Right. What was the lower limit for x? When we were talking about x's, the lower limit was 0. So let's put in 0 instead of x and see what happens. If x is 0, It's kind of obvious that u is 2, isn't it? 0 plus 0 plus 2, which is 2. So 2 is our new lower limit. Our new upper limit, I let x equal 2. That's the upper limit for x. So what's u going to be? U is x squared plus 2x plus 2. So it's 2 squared plus 2 by 2 plus 2, which is 4, and 4 is 8, and 2 is 10. So the upper limit is now 10, and I am never going back to x's again. Okay? It is easy to do, let's face it, isn't it? It's easy to change those limits. Right. What happens when you integrate 1 over u? You get log u. So isn't that a half log u? And this time there are limits, so it's a bit different. Do you notice that there's no plus c? Okay, you don't put down the constant when you have a definite integral. It's only indefinite when you don't know what the limits are. This time I do know the limits, so there's no need for a c. Okay? I know exactly what c is. Now, how do we deal with limits on the next line? What do we do with them? You put in the upper limit and you subtract what you get when you put in the lower limit. So isn't it just half into log 10 minus log 2? Okay? A half into log 10 minus log 2. So let's think about logs. What does subtraction mean in logs? Division. So what's log 10 minus log 2? Sorry, it's log 5, isn't it? Okay, because 10 divided by 2 is 5. So that's a half log 5. Now, let's face it, you would have got full marks for that, but just in case, and again, so we can practice our logs a bit, what happens if I brought that half through the log? Doesn't it go up as a power? So it'll become 5 to the power of a half. Isn't that the square root of 5? So I could also say that the answer is a half log root, or sorry, log of root 5. Is that okay? They're both equally correct. By the way, anybody who got this last year, full marks. Anybody who got this, full marks. The only reason I'm doing this is in case they said write your answer in the form log of root a, where a is an element of n. Okay, do you know the kind of question I'm talking about? So we all okay with that question? Now, have a good look at that. You've got it written down anyway. Have a good look at it. And wait till we see what part 2 is. Integral from 0 to 2. Notice the limits are the same. X squared plus 2x plus 2 divided by x plus 1 dx. The examiner is trying to mess with our heads. Isn't that the exact same question upside down? It's the exact same thing upside down. So it does make life a bit harder, doesn't it? Now, there are 2 ways of doing this, okay? And I don't have time today to show you both. So I'm just going to show you the efficient way, okay? Now, for the next couple of seconds, you're going to think I've gone crazy. I'm going to do something that you would not expect, okay? Over on the right-hand side, I'm going to pretend I don't know how to divide 34 by 10. I'm picking 2 numbers that don't divide into each other deliberately, okay? So over here in our rough work, let's go back to primary school and do long division. How would I divide 10 into 34 if I was in primary school? First thing I'd do is I'd say to myself, how many times does 10 go into 34? 3 times. So I'd write in a 3 on top, wouldn't I? Then I'd multiply 3 by 10 and I'd get 30, wouldn't I? Then what would I do with that 30? Wouldn't I change the sign? And 34 minus 4 is 4. Yeah? So would you agree or disagree with this comment? 34 divided by 10 equals 3 plus 4/10. That is obviously 100% correct, isn't it? 34 divided by 10 is 3 4/10. In other words, look at it carefully. 34 divided by 10 equals the top number up here, 3, plus the remainder divided by this. Is that okay? We all happy with that? Obviously, what I've done here is the key to what I'm going to do over there. So can we write down a rule? If the highest power of x on the bottom, if the highest power of x on the bottom, in this case it's x to the power of 1, isn't it? On the bottom. If the highest power of x on the bottom of a fraction is smaller than or equal to the highest power of x on top, if the highest power of x on the bottom is smaller than or equal to the highest power of x on top, long division is the way to go. If the highest power of x on the bottom of a fraction is smaller than or equal to the highest power of x on top, then long division is the way to go. Okay? You don't have to do long division. I would have to say that. How many of you would say your instinctive reaction here would be let u equal x plus 1? It would work. My God, it would be head-wrecking though. Okay? It would take you about twice as long as what I do, because when you'd let u equal x plus 1, du dx would be 1. So du would be equal to dx. So that part would be easy. But the problem is, if u equals x plus 1, then x equals u minus 1. So you'd have to put u minus 1 here instead of x, square out that bracket. You'd have to put in u minus 1 here instead of x, multiply that out. Then you'd have to divide anyway, okay? And you'd have to change your limits. I am never going to substitute here. I am never going to need to change limits. I'll have the question done in half the time and half the amount of paper used. Okay? So, keep your eye on that 34 divided by 10 example. I'm going to keep it on the screen so you can see that I'm not trying to con you. X plus 1, I am now going to divide that into x squared plus 2x plus 2. Whether it divides in evenly or not is irrelevant. Like over here, didn't I deliberately pick two numbers that didn't divide into each other to be awkward? Okay? Now, I know everybody in the room is able to do long division, so this should not be hard. What's x squared divided by x? X. What do I now do with that x? Multiply it down. X by x is x squared, x by 1 is plus x. Now what do? Change signs. Plus becomes minus. You see, everybody does know how to do this. The x squareds disappear. What's 2x minus x? X. And then you've got your plus 2. Now what do? I have to keep going till I end up with a remainder, a number. Would you agree? So now I go x divided by x. What's x divided by x? 1. What do I do with that 1? Multiply it by both of those. So that's just x plus 1. And then plus becomes minus, gone, gone, and my remainder is 1. Everybody okay with that? Now, using what you learnt from what I did up here, using this bit, how could you apply it down here? Isn't this the same as the integral from 0 to 2 of x plus 1? The number on top. What did I end up with on top? X plus 1. Plus 4 over 10 plus 1 over x plus 1. All happy? Plus 1 over x plus 1 dx. Now, isn't that easy to integrate? Start integrating. Integrate x. What do you get? X squared over 2. Does everybody fully understand what I just did? Okay? I only used the 34 over 10, so we didn't spend a half an hour arguing over whether I was right or not if I went straight in and did this. Okay? The 34 over 10 is only just to reaffirm that I'm right. Okay? Integrate x, you get x squared over 2. Integrate 1, what do you get? you get x. What's our sneaky way of integrating 1 over a linear function? What's the number in front of x? 1. Isn't it 1 over the number in front of x by the log of the bottom line? And the number in front of x is just 1, isn't it? So in actual fact, isn't it just the log of the bottom line? So plus the log of x plus 1. And that all has to go from 0 up to 2. No substitution, no awkward messing around with u's and x's and changing limits. Simple. Right, first of all, put in 2 instead of x. So that's 2 squared, which is 4 over 2, plus x, which is 2, plus the log of 3. Are we agreed? Minus what you get when you put in the lower limit. 0 plus 0 plus the log of 1. What's the log of 1 to the base a million? 0. What's the log of 1 to the base 57? 0. The log of 1 is 0 no matter what the base is. Okay? So ln of 1 is just 0. So everything in that rounded brackets just disappears. Okay? It's all 0. Now 4 over 2 is 2. So my final answer is 4 plus the log of 3. Now, isn't that much shorter than doing substitution? Now, you'd have to, like, obviously, first of all, agree with me on the fact that in the leave insert, that stuff is not going to be there. Having said that, if you forget how to connect this with this, it wouldn't be any harm to just pick 2 random numbers and do long division and just verify it from there. Like, if you wrote that on the back of your exam paper, wouldn't it tell you where to put stuff when you do your long division with the real functions? So it's no harm to actually do it. If you get stuck, just pick 2 numbers like 27 and 10 and divide them in and see what you're left with. And that will make sense in your head, and then just apply that to the functions. But the main thing is, how did I know to use it? What was the key? How do you know to use long division? If the highest power of x on the bottom is smaller than or equal to the highest power of x on the bottom. Okay, so can you try this one at home tonight? Like if you're able to do this one, I don't have time to do it, but if you're able to do this one, we've got no problems here. Integral from 2 up to 3 of x plus 1 over x minus 1 dx. It is long division, isn't it? But would you agree the highest power of x on the bottom is actually equal to the highest power of x on the top? Is that okay? So just do that at home, just to clarify in your own head that you know what's going on here. Is that okay? Sorry, I'll just leave it there for another second. Integral from 2 up to 3 of x plus 1 over x minus 1 dx. Right, now let's move on to trig integrals. Okay? Now, these are very, very important because of their relevance in project maths and because of the fact that the examiners don't want to have 2 different exams that have 2 different standards. So this is a major area of crossover. Okay? So the heading is trig. Right, what I'm going to do is I'm going to do something for cos and I'm going to ask you to do the same thing at home for sine. Is that okay? I'm going to just work out what is the integral of cos ax dx, where a is just a number. Is that okay? In other words, I'm going to prove a little bit of a formula that gives us a license to use it from there on for the rest of the class. Okay? Right. Well, if you were chancing your arm, what substitution would you make? Letting u equals ax seems like a fairly safe bet, doesn't it? So let's try that. Let u equal ax. So du dx is equal to a. Agreed? So du equals a dx. So 1 over a du equals dx. So u is ax, and 1 over a du is dx. Now move back to here, the left-hand side. 1 over a, the integral of cos u du. Because cos of ax is actually just cos u, isn't it? What do you get when you integrate cos? Sine. So integrate cos u, you get sine u. Okay? So that's 1 over a sine u. And by the way, we're back to indefinite integrals, so I better put in a plus c. Now, what was u? It's 1 over a sine ax plus c. Okay? So 1 over the number in front of x by the sine of the angle. So if that was cos 7x, wouldn't this be 1/7 sine 7x? If that was cos a million x, it'd be 1 over a million sine a million x. Is that okay? Plus c. What I want you to prove at home is just prove this. That the integral of sine ax dx, it's going to be very similar with one small difference. Why is the minus sign coming in there? It's almost identical. The problem is that when you integrate sine, you get minus cos, not plus cos. Okay? So minus 1 over a cos ax dx. I want you to justify that at home by using the same idea, let u equal ax. So what would you get if I asked you to integrate sine of 100x? Minus 1 over 100 cos of 100x. Is that okay? Right, so here we go. Here's what I think is a lead contender for both exams. Okay? Project or non-project. Find the integral from 0 up to pi over 2 of cos 5x sine 3x dx. Cos 5x sine 3x dx. Any suggestions, anyone? The hint for the day is think trigonometry. Sorry? Yeah, a formula from the log tables. Like basically what I'm saying to you here is for the next 20 minutes or so, any integrals I do, the key is the log tables. Is that okay? You know the trigonometry pages in the log tables? You make sure you have them open on the desk beside you when you're doing these integrals. Now, in the log tables, you'll see this formula. 2 cos A sine B equals the sine of A plus B minus the sine of A minus b. It's on about page 14 or 15 or 13 or something like that. You see that? Okay, 15. So 2 cos sine of a plus b minus sine of a minus b. It's the last, they're up in the top right hand corner and it's the fourth down. So all I got to do is apply this to this. Now, who does accountancy in the room? If money goes out of one place, doesn't it have to go into somewhere else? Okay, money can't just vanish. Okay, not in a business anyway. It has to go from one account into a different account. So the problem I'm having at the moment is there's a 2 in the formula, but I don't have a 2. Okay? But there's a 2 in the formula. So what do? Integral from 0 to pi over 2. Wouldn't life be great if I could just do this? Wouldn't it? If I could just put in that 2 there, wouldn't life be great? But if we think from an accountant's point of view, I can't put in a 2 on top unless I put in a 2 on the bottom. Is that okay? I can't do that. I have to put in a 2 in both places. Okay? So now where are we? A half the integral, notice I haven't done any integration yet at all, of the sine of a plus b minus the sine of a minus b. Now, in our case, would you agree a is 5x and b is 3x? Is that okay? So 5x plus 3x is 8x. So isn't that going to be the sine of 8x minus the sine of 5x minus 3x, which is 2x dx. Is that totally okay? Isn't this the question I've asked you to prove at home? That if you integrate sine ax dx, you get minus 1 over a cos ax. So what does this become? Well, a half into minus 1 over the number in front of x by cos 8x. Because if you integrate sine, you get minus cos. Plus a half cos 2x. From 0 up to pi over 2. Is that okay with everybody? Yes? Right, now what I'm supposed to do is put in the lower limit, or sorry, put in the upper limit and then subtract what I get when I put in the lower limit. Now, I'm about to do a step that's totally unnecessary in this question, but I actually want to do it because I want to show you it can be done. Okay? Here's what I'm going to do. A half into 1/8 cos 8x minus a half cos 2x. What have I done there? I've just reversed the signs, haven't I? Now, I have to say, it's a bit of a pointless exercise here, other than I just want to show you it can be done. So I have just decided, unanimously, I'm going to change signs. Okay? I'm allowed to do that as long as I do what? Swap the limits. Is that okay? So you can change signs if you want. If you have a lot of minus signs at the end of the question, you can change all the signs to make them pluses, and all you got to do is swap your limits. Okay, now as I said, that line was kind of unnecessary, but let's run with it. Okay, just for demonstration purposes. So that's going to be a half into 1/8 cos of 0 minus a half cos 0, because obviously if I put in 0 instead of x, 8 multiplied by 0 is 0, and 2 multiplied by 0, well, that's 0 as well. Okay? Minus 1/8 cos 4 pi, because 8 times pi over 2 is 4 pi, isn't it? And then minus a half cos pi. Right, off the top of your heads, what's the cos of 52 pi? You should know off the top of your heads. What's the cos of 52 pi? I picked an awkward number, but it should be obvious. 1. What's the cos of 127 pi? No. It's not 1. Sorry, Connor. Cos of 127 pi. What's the cos of 127 pi? It's minus 1. What's the cos of 1,000,002 times pi? 1. What's the cos of 19 pi? Minus 1. If you have an odd number multiplied by pi, the answer is minus 1. And if you have an even number multiplied by pi, the answer is plus 1. So all you need to know is whether the number is odd or even. You don't need to think too much about it beyond that. So, let's write it down. Cos of n pi equals 1 if n is even, and sorry, not 2, minus 1 if n is odd. Okay? Now, by the way, the cos of 0 is 1 as well, isn't it? So this thing here is going to be 1, 1, what you reckon? 1. How many pi's is that? 1 pi, 1 is an odd number, so it's minus 1. Okay? So looking across there, this is 1, this is 1, this is 1, this is minus 1. Okay? Now, some things are probably going to cancel here, and we'll see in a second which ones do. I think you'll agree that that bit there is going to cancel with that bit there, isn't it? I'm going to have plus an eighth minus an eighth. This is going to be minus a half. Now, minus a half by minus 1 is plus a half. But don't I have another minus sign out here in the long grass waiting? So minus by plus again is minus. So I'm going to have in here minus a half minus a half. Is that okay? Do you all understand why? Minus by minus is plus, by minus is minus. Okay? So that's going to be a half multiplied by minus 1, which is minus a half. Okay? Now again, we don't have enough time to do a lot of examples on that, but I think that one is just an example of anything. If you see a product, okay, you change it to a sum or a difference using those formulas on page 13 or whatever it was. Okay, so if you see cos multiplied by sine, cos 5x, cos 3x, sine 7x, sine 2x, anything like that, look in the log tables for your answer. And if there isn't a 2 in it, put in a 2 on top, but then compensate by putting in a 2 on the bottom. Okay? So anybody, any questions on that? None? Right. Here's unusual questions. Integral from 0 up to pi over 2 of cos x sine to the power of 6x dx. So the heading is here is kind of powers of sine and cosine. Integral from 0 to pi over 2 of cos x sine to the power of 6x dx. What do you reckon? By the way, log tables are no help to me here. There's no point in me looking in the log tables and trying to look for a formula that's going to help me out. What happens when you differentiate sine x? If you differentiate sine x, you get cos x. If you integrate sine x, you get minus cos x, but if you differentiate sine x, you get plus cos x. If I differentiate sine x, I get cos x. You know what? Let's let u equal sine x. Okay? There's only two options here. Either let u equal sine x or u equal cos x. So we'll go with u equals sine x. Doesn't that mean that du dx is cos x? And doesn't that mean that du equals cos x dx? So u is sine x and du is cos x dx. Okay? How does this all change here then? Let's worry about the limits in a minute. Well, what's going to be going in instead of cos x dx? Just du. What's going in instead of sine to the power of 6x? Just u to the power of 6. Okay? Now, let's think about the limits. U equals sine x. So if x is equal to 0, what's u? It's the sine of pi over 2, which is 1. Is that okay? So u is the sine of pi over 2, which is, oh sorry. Sorry, I'm looking at the upper limit. It's silly. So u is the sine of 0, which is 0. By the way, what's the sine of n pi? Sine of 100 pi is the same as the sine of 57 pi, is the same as the sine of 2 million pi. What is it? 0. The sine of any number, any whole number multiplied by pi is 0. Okay? The sine of any whole number multiplied by pi equals 0. So let's just write that in there. Sine n pi equals 0 for all, not just n an element of n, it actually works for z. Even if it was negative, it'd still be 0. Okay? So now I need to think about pi over 2. If x is equal to pi over 2, that means that u equals the sine of pi over 2. That's where I went rambling a minute ago, which is 1. So the new lower limit is 0, and the new upper limit is 1. So we're going from 0 up to 1. And so now it's just a simple integral. U to the power of 7 over 7, from 0 up to 1, which is 1 over 7 minus 0, which is 1 over 7. Is that okay? That's it. So 1 over 7. Everybody all right? Okay. Next up, what I'm going to do is I'm going to call this section weird integrals that have come up. Okay, just unusual ones, really strange looking ones. That kind of, we haven't seen the rules for them yet. Okay? What happens, usually actually what happens when an examiner asks a new type of a question in an even cert paper, they tend to actually, instead of avoiding that from then on, they tend to ask it again a year or two later and change it a bit. Okay? So here's an exam question from 1995. At least I think it is. I'll write down 95. I'm fairly sure I'm right. Integral of 1 over root x by root x plus 1 dx from 1 up to 4. The limits might be different, but the rest of the question is identical. So the integral from 1 up to 4 of 1 over root x into root x plus 1 dx. You know what? I'm going to stop talking for about 30 seconds and see, can you come up with a substitution? What would you do here? Would you agree with that? It's true, but my God, it's stupid. That is an unbelievably bad thing to do. That is terrible. I have just made the question about 1,000 times more difficult than it needed to be. Okay? I tend to live by a rule that unless I'm doing complex numbers and I'm multiplying top and bottom by the conjugate of the bottom line, I never, ever, ever multiply out brackets on the bottom. Okay? It is rarely the right thing to do. So if I actually did that in the leaving cert, I would now be in really dire straits. Okay? I would have no hope of spotting what the substitution is. So don't multiply out brackets on the bottom line. How many of you actually did that? Yeah, I thought a fair few people would. Okay? Do not multiply out those bottom brackets or you're giving yourself a headache. Right. There are actually two possible intelligent substitutions here. Okay? One that would work perfectly well is to let u equal root x. Yeah, that would work absolutely brilliantly. But you know what would be even better? Let it equal to root x plus 1. Because what's going to happen when I differentiate the 1 anyway? It's just going to disappear, isn't it? So the 1 is irrelevant. Okay, I just put it in to be official, but I don't. It's not going to have any impact. Now, isn't that x to the power of a half plus 1? I have to write it like that. Now, I'm living in the hope that when I differentiate this, I'm going to see something that I recognize. Okay? So anyway, differentiate x to the power of a half, what do you get? Don't you get a half x to the power of minus a half? Okay? What does that mean? X to the power of a half means square root above a division line. X to the power of minus a half means square root under the division line. Is that okay? So because it's x to the power of minus a half, the root x goes underneath. Is that in any way recognizable? I'm looking back at the original question and I'm thinking, you see this bit here in the brackets? Am I just going to be putting in u instead of that? So if I cover that, what am I left with? Dx over root x. Dx over root x. Can I recognize that over there? Right, I'm thinking if I did this. If I cross-multiplied and brought the dx up there, and cross-multiplied and brought the 2 up here, wouldn't I have 2 du equals dx over root x? Yes? So now let's have a look back here, and we'll worry about the limits in a minute. What's going to happen to my 1 over root x dx? This bit here that I'm shading in yellow. What's going in instead of that? 2 du. And can't the 2 go out here? So 2 du. Right, so what haven't I shaded in yellow? I haven't shaded in 1 over root x plus 1. But there isn't root x plus 1 just u. Okay? So isn't that again our favourite integral? 1 over u du. How many times has that happened today? Loads of times. Now I'm going to quickly change the limits to save time. U is the square root of x. The bottom limit for x was 1 and the square root of 1 is 1. The upper limit for x was 4 and the square root of 4 is 2. Is that okay? Now obviously in the exam you explain your limits. I'm just trying to save time. Isn't that going to be 2 log u from 1 up to 2? Which is 2 into log 2 minus log 1. What's log 1? Isn't it 0? Log to any base of 1 is just 0. So that's 2 log 2, which is log of 4. Where did the 4 come from? Isn't 2 log 2 the same as log of 2 squared? You bring that 2 through the log. This 2 here, bring it through the log, it becomes a power. Okay? So it becomes log to the power of log of 4. Now, you'd have to say that's a fairly horrible question, isn't it? But it only took about 5 lines. It was actually half a C part. I was going to say a full C part. It was half a C part, I think, in 1995. Okay? Now, 2 years later, here's what appears on the leave insert. I want you to do this at home. Integral from 1 over root 3, actually, sorry, from 1 up to root 3 of 1 over t plus root t dt. That's exactly the way it was written second time round. You notice anything? What did I say would have been the stupidest thing that I could have done in the previous question, and I actually did it and then said it was wrong? When I multiplied out those brackets, didn't I get x plus root x? Look at the bottom of that. What do you see? T plus root t. Isn't it the same question? Same question with different limits. However, what I should do here, I just do the first line for you. From 1 up to root 3. Now isn't it identical? Okay? It's absolutely identical now, isn't it? So again, just finish that off for homework. Okay? You know exactly what to do. Are we all okay? So no problems, no? Right. Right, next question. This is another one taken from a leave insert paper. Now, I'm not going to be able to go into the rules of integration again tomorrow. And unfortunately, I'm probably not going to have time to do sine inverse and tan inverse integrals. Okay? They're very, very important, but I'm just not going to be able to take on them in the next 10 or 15 minutes. They need a bit more time. Okay? But this one, believe it or not, ends up being one of the two that I've just mentioned. Integral from 0 up to log of root 3 of e to the x dx over 1 plus e to the power of 2x. Again, I'll give you a 30-second head start. Have a bit of a think about it. So here we have exponentials and logs. What's so special about e? The e to the power of x function. If I differentiate e to the power of x, or if I integrate e to the power of x, I get e to the power of x. Okay? Whether I integrate it or differentiate it, it doesn't matter. It just stays the same. So what are your thoughts? Would you agree with this? By the way, this is the right thing to do. I'm not trying to trick you or con you this time. Generally, when you see e to the power of 2x or 2 to the power of 2x, isn't this the intelligent thing to do? Isn't e to the power of 2x the same as e to the power of x squared? Yeah? Now, what's so special about e to the x? If I differentiate e to the x, I get e to the x. I think maybe we should let u equal e to the x. What do you think? So let's let u equal e to the power of x. That means that du dx is also e to the power of x, which means that du equals e to the power of x dx. Yes? Now, I'll worry about the limits in a second. That's quite a big deal, so I'll just leave that for a minute. What about e to the x dx? What's that? Isn't that just du? Okay? That's just du. Over 1 plus u squared. Now, this line is effectively doing nothing. I'm just writing it down so something is easier to explain. Isn't that effectively the integral of 1 over 1 plus u squared du? Yes? So you're entirely happy with that? Okay, now let's focus on the limits. Okay? So, limits. U equals e to the power of x. So, if x is equal to 0, this one is a no-brainer. U equals e to the power of 0. And isn't anything to the power of 0 equal to 1? No matter what I put in, the answer is 1. So, the bottom limit is 1. However, it's the top limit that I'm really worried about. Okay? If x equals log root 3. Sometimes, by the way, the harder it looks, the easier it is. If x is equal to log root 3, would you agree that u is equal to e to the power of log root 3? I just put in log root 3 instead of x. What is the relationship between e to the power of x and log x? They wipe each other out. Okay, any of you who were here at Christmas will realize that when we were doing differentiation, we spent a lot of time talking about the fact that e and log were the inverses of each other. They were the opposites of each other. If e goes across an equal sign, it becomes ln. If ln goes across an equal sign, it becomes e. Okay? E is the opposite to log. Squaring is the opposite to the square rooting. So like say, for example, what's the square root of 3 squared? 3. What's the square root of 5 squared? 5, because square root is the opposite of squaring. So what's e to the power of log root 3? If e and log wipe each other out, what are you left with? Root 3. It's just root 3. So 1 up to root 3. God, we saw root 3 a lot yesterday, didn't we? Didn't root 3 appear loads of times yesterday doing the Moivre's theorem? Whenever I see root 3s, my brain automatically clicks into, is it 30 degrees or 60 degrees? If I see root 2s, I generally tend to think, I wonder is it 45 degrees? Because you see, the sine and cos of 45 is 1 over root 2. The tan of 60 is root 3, and the tan of 30 is 1 over root 3. So automatically now, my brain is starting to move to trigonometry a bit, isn't it? Now, the very first substitution we did today was, we said let u equal the bottom line. If you let u equal the bottom line here, you're going to end up in the middle of a nightmare. Okay, remember I said there are exceptions. Welcome to the exception. Okay, so can you write this down? If there is an x squared on the bottom of a fraction, if there is an x squared on the bottom of a fraction and the top line is constant, that's the key. Top line here is constant. If there's an x squared underneath the division line and the top line is constant, then it is definitely a tan inverse integral. Then it is definitely a tan inverse integral. So the tan inverse integral is the exception to the rule. Is that okay? So is the sine inverse one, by the way. So what is that rule? The integral of 1 over a squared plus x squared dx. Can you remember it? It's 1 over a tan inverse x over a plus c. That's me just copying a rule from the log tables. Is that okay? So how does that compare to here? Instead of x, I have u. Instead of a, I have 1. Isn't 1 just the same as 1 squared? So if I want to apply that formula, don't I just have to put in 1 instead of a? So what's it going to be? I really spell it out. 1 over 1 tan inverse x over 1 from 1 up to root 3. Are we agreed on that? Because a is 1. Just comparing to the formula. Okay? Now obviously 1 over 1 is 1, so let's just ignore that. I don't need to be wrecking my head writing that down. I don't need to be writing that down either. Isn't it just tan inverse x? So it's tan inverse x from 1 up to root 3, which is tan inverse root 3 minus tan inverse 1. Okay? Now here is a stupid mistake of Olympic proportions. Equals 60 minus 45 equals 15. That is one hell of a mistake. That will make the blood freeze in the examiner's veins. It doesn't sound too bad though, does it? Like tan inverse root 3 is 60 degrees. Tan inverse 1 is 45 degrees. The only thing is, what is it? What's the problem? You absolutely cannot use degrees. Is that okay? That is absolutely out of the question. Okay? You never ever use degrees when you're doing any of these integrals, okay? It has to be radians. That's the reason why radians are used at all. They work in engineering formulas, they work in physics, they work in chemistry. Degrees don't all the time. Whereas radians will never let you down. So it's not 60 degrees, it's pi over 3. It's not 45 degrees, it's pi over 4. Now that's obviously, the LCM is 12, so that's going to be 4 pi minus 3 pi over 12, which is pi over 12. Is that okay? So the answer is pi over 12. Everybody all right with that? So what is the trigger that makes you recognize a tan inverse integral? You see an x squared underneath a division sign, or division line, but the top line is constant. If there had been a u on top here, sorry, say if it was something like 4u over 1 plus u squared, what would you do? You'd let u equal the bottom line, wouldn't you? Oh, sorry, 4x over 1 plus x squared, you'd let u equal the bottom line. The exception is if the top line is constant, then it's a tan inverse. Is that okay? Now that can bring up some very, very weird questions, some of them involving completing the square. Okay?